Hello class, today we're going to continue on with section 2 of chapter 2, talking about physical properties. So remember, this is going to be part 2. So last time we were talking about why physical properties are useful. And we said they're useful because they help us identify things. They're useful because we help pick out what type of material we should use based on their properties. And the third thing that we are going to talk about is they're very useful to help separate mixtures. So let's actually review what a mixture is. So a mixture is two or more substances physically blended. So we talked about milk, cereal, chicken noodle soup. So these are physically blended. So the key word there, physically. So when we do talk about physical properties, we can use these physical properties to separate mixtures. So what processes are used to separate mixtures? Well, two that we're going to talk about is filtration and distillation. They're very common separation techniques, but they're not the only ones. So we're going to talk about a little bit more. So the first one we're going to hit on is filtration. Filtration is the process that separates materials based on the size of their particles. So that's very important to know. I will ask that on your test. So typically filtration is set up similar like this, or instead of an Erlenmeyer flask, you might have a beaker. So typically you have a solid and a liquid mixed together. So this is your mixture. And you're going to pour it down. This thing is called a funnel. And then there's usually some kind of filter paper inside of it. So anything that is liquid and have tiny particles are going to flow through and end up down here on the bottom in your filtrate. But anything that is too big to go through the filter is going to stay up here on top. So it does help separate big and small particles. So you can separate hot tea, as a good example, from loose tea leaves by pouring the mixture through a strainer. For example, the tea is going to go through the strainer because it's tiny, but those leaves are going to stay behind. We actually use filtration when we make coffee. Coffee uses coffee filters. So those coffee grains stay behind on the filter and you're left with the delicious coffee. And again, like I said, in lab, we use filter paper. Okay. Another example of using filtration is right here's a picture of students sifting or filtering dirt. And inside here, they have like a wire screen. So anything that is small can make it through that screen and fall back down. But things that are large, like for example, pottery, is left behind, and then they can say, oh, this is a nice piece of pottery. If you've ever heard about the gold rush, they actually filtered or sifted out water and they left gold speck particles behind on their screen. The second one we're going to hit on is distillation. Now, I don't do a distillation lab with you guys. It's actually pretty complicated to set up. However, we do still teach it. So distillation is the process that separates the substances in a solution based on boiling points. Boiling points. So this is why this is a very complicated setup. Typically, you have a burner, which is a fuel source, and then you have a flask that contains your mixture. So contains your mixture. We'll add that in there. What happens is this heat from this burner is going to boil the mixture you have in here. And one of those mixtures usually has a different boiling point. So one of those mixtures is going to boil off and turn into a gas. That gas is going to flow through what's called a condenser. Now this condenser has cold water in it, so it cools that gas back down to where it turns back into a liquid. So when you're hopefully finished, this flask should contain one part of your mixture, and this flask should have your other part because we separated it based on boiling points. The third one that is not a common one, but I am actually going to show you a video, and my kids last year did this. Unfortunately, because of COVID, you're not going to be able to do this, but it's called chromatography, or you might hear it be called chromatography. You're going to hear it be pronounced different ways. So what chromatography is it separates mixtures that by having the components of that mixture travel across or through another substance at different rates. Okay, that might actually sound confusing, so let's actually bring up a picture. So what I mean by here is your mixture. One second, I gotta sneeze. Oh, excuse me. Here's your mixture, and it has different particles in it: yellow, red, and green. So the yellow, red, and green are your components. And what they do is they travel across another substance. So they're going to travel across this paper. And the way they travel across this paper is that you usually dip it in water, and the water is going to carry it and travel through it. So there are different types of chromatography. There's paper, liquid, gas, and thin layer. I'm actually on Friday going to show you a video of paper chromatography. So you're going to kind of see how you can take ink and you can separate it into the different colors that make it up. Now, there are more techniques other than the ones that I've talked about. You can use physical separation to separate things. For example, right here, they have a solid on the bottom and a liquid on top. And what they're doing is they are pouring off that top liquid. So decant is a word that is used to mean pour off this top layer. So then we're left with the bottom layer. You can use tweezers to pick something out. If something is magnetic, you can use a magnet, because not everything's magnetic. And then, like I said right here, this is decanting. Think of other ways you separate things. If you don't like something on a salad, you pick them off with your fingers. So there are so many different separation techniques. So I'm left with a few assessment questions that I'm going to ask you, and let's see what you can take away from this lesson. Number 1, it says, which of the following is not a physical property? So I'm going to let you take a moment to answer this. So pause the video, and then we'll go over the answer. If you chose C, you are correct. So C was not talked about in this lesson because C is not a physical property. We're going to learn in the next section that flammability is a chemical property. Okay. Number 2, which of these materials is not malleable? So I want you to see what you can guess, and we'll go over it. If you said sea glass, you are correct. Now remember, a lot of metals are malleable. So copper's a metal, aluminum's a metal, and so is gold. And remember, malleable means that you can hit it with a hammer and it doesn't shatter. Well, I'm going to tell you right now, if you hit glass with a hammer, it will break. See. Number 3, in choosing material for use as a wire to carry an electric current, which property would be most important? So think about which property meant carrying electricity. If you said A, conductivity, you are correct. So remember, conductivity is the ability to carry heat, but also electricity. And number 4, which of these statements best describes a physical change in a pure substance? So A, the substance changes into one or more new substances. B, some of the properties of the substance change, but the material remains the same. C, the properties of the material do not change and the material remains the same. Or D, the substance is separated into 2 or more simpler substances. So I want you to pause this video and see what you think your answer is. If you chose B, you are correct. The reason A is incorrect is because it can't change into a new substance. If it changed into a new substance, it means that the composition changed. And remember, physical composition cannot change. Now, the reason C is incorrect is because it says the properties do not change. But remember, properties can change. The size can change, and so can the shape. The second part is true. It does remain the same. And D, the substance is separated into two or more simpler substances. That has to do with separation and not with physical changes. So the answer is B. And this is the last assessment question, and it says the process of filtration uses the difference in boiling points. So think about what filtration means. True or false? If you chose false, you are correct. Filtration actually uses differences in particle size. Boiling points is going to be based off of distillation. So understand the difference between those two. So false, distillation. Okay, so let me know if you had any questions or you struggle with any of this material. Make sure that you guys are keeping up with this and following the video. And let me know if you have any questions.